In this video, we're gonna solve one example of extreme value theorem, and we are gonna find global maximum or minimum of the function x squared minus xy plus 2y on a rectangle as D. Okay, so let me show it to you the graph of the function first. So this is the graph of the function f, x squared minus 2xy plus 2y, and let's see, and the domain D that we consider, it's this rectangle in here. We're gonna see what is the maximum or minimum of this function on this domain. Okay, just this part. Okay, so let's start writing the solution. I'm gonna find the critical points first. The critical points. For finding them, I'm gonna find partial derivative with respect to x, which would be 2x minus 2y. Partial derivative with respect to y would be negative 2x plus 2. I'm gonna set both of them equals to 0, and I'm gonna solve this system of equation. So for finding that, I just noticed that the second equation, x would be equal to 1. I'm gonna plug in into the first equation, and then I get negative 2y is equal to negative 2, therefore y is equal to 1. So the only critical point is 1, 1, and the value of the function at the critical point is, just plug in 1, 1 into here, I get just 1. Okay, so is this a saddle point, minimum, maximum, or what? I'm gonna find D, partial derivative of, let me write the formula for D first, fxx, fxy, fyx, and fyy. fxx is equal to 2, fxy negative 2, fyx negative 2, fyy 0. So it is negative 4, which is negative, therefore the point 1, 1 is a saddle point. Good. So now that I found the critical points, that was the first step. On the second step, I just look at the boundaries of D. Okay, so what is D? Let me bring D here. So I'm gonna graph x-axis, y-axis, and then the x is from 0 to 3 and y is from 0 to 2. Okay, oops, and let me graph it in here. So that's the y between 0 to 2, and then x between 0 and 3. Okay, for boundaries of D, I just need, for example, this line in here, which would be what? Equation of that is y equals to 0 and x between 0 and 3. Okay, let me call it 1. The boundary equation 1. For the boundary equation 2, I'm gonna look at this part, which is x equals to 0, y between 0 and 2. This is equation 2. For equation 3, I look at this part, and on here, y is equal to 2, x between 0 and 3. This is equation, actually let me make this 4, and I'm gonna make this one x equals to 3, y between 0 and 2. This is equation 3. Okay, Now, for each of these equations, I need to find maximum or minimum of f. So what is the function fxy? The function fxy, and the question is x squared minus 2xy plus 2y. So x squared minus 2xy plus 2y. Okay. On the first boundary, I have y equals to 0 and x between 0 and 3. Okay. Then I'm gonna plug in y equals to 0 into the equation. So I get f of x and 0, which would be what? Just x squared. What is this graph? This is actually a parabola, x, y. This is a parabola like this. And then x is between 0 and 3. So between 0 and 3, we just consider just this part of the graph. So this part of the graph has a minimum at the point, let me raise just a little bit. It has the minimum at 0, 0, and it has the maximum at 3 and 0. It's 0 because y is equal to 0. You shouldn't plug in into here. Y equals to 0, so that's the point, okay? And this is the point is 0 and y is 0. Actually, this is not y-axis, this is z-axis, right? Because this is z equals to x squared. Okay, so now I found these 2 points. Let me just go to the next one. For the next one, equation 2, I have x equals to 0, y between 0 and 2. So in that case, what is my function? I have f of x is 0, and I just keep writing y. So x is 0, this is 0, so I get 2y. Now, what is the graph of this function? This is just a line. This is z equals to 2y. Actually, let me label the axis correctly. This is z-axis, this is y-axis. And then y is between 0 and 2, so 0, 1, and then 2. And I get just this part of the graph I needed, and along that part I have a minimum at this point. This point is y equals to 2 and then x equals to 0. Yeah, y is equal to 2, x equals to I'm sorry, y equals to 0, x equals to 0. And I have a maximum at, you see, x is equal to 0, and then y is equal to 2. Very good. How about the third boundary? The third one is x equals to 3, y is between 0 and 2. For that, I have f of x is equal to 3, and then I have y. Just plug it in there. I get what? I get 9 minus 6y plus 2y. So 9 minus 6y plus 2y, which would be, if I want to simplify that, it would be 9 minus 4y. Okay, so what is the equation? It's still a line. Let me graph the line, y and then z. When y is equal to 0, z equals to 9. And then when z is equal to 0, y is equal to 9 over 4. Somewhere in here. Just assume that, for example, this line in here, 9 over 4. Okay, and x is between, and y is between 0 and 2, so between 0 and 2, so somewhere in here. 2, okay, just this part of the graph I need it. And as you see, we have a minimum at this point. What is this point? We have a minimum. The x coordinate of this point is x equals to 3, and then the y coordinate of this point is y equals to 2. How about the maximum? The maximum of this function would be at this point, you see, and on this point y is equal to 0, and I need to keep writing 3. Now let's look at the fourth boundary line, which is y equals to 2x between 0 and 3. So I'm gonna plug in y equals to 2 in here, so I get x squared minus, plug in 2, I get 4x plus 4. Then it's a parabola, but it's a little hard to graph. That's why I use the methods that I already know. Let me call this function g of x. So I just have a simple function of just one variable, and I need to find the maximum or minimum of that on this boundary interval. So to do that, I'm going to take derivative of that with respect to x, which is 2x minus 4. I'm going to set it equals to 0. X would be equal to 2. I'm going to use the second derivative, and since the second derivative is positive, the point 2 and the y coordinate of the point is still 2, is the local mean. Okay, how about the other points? So let's see, how about g of the point 0 and g of the point 3? Okay, g of the point 0 is 4, g of the point 3 is 9 minus 12 plus 4, which is 1, and g of the point 2, the local minimum, is, plug in 2 in here, I get 4 minus 8 plus 4, it's equal to 0. That's why we get a minimum in here and we get a maximum at 0. But let's look at all the points that we got. We got the point 0, x is 0, and y for all of them would be 2. So I get 3 and 2, and I get 2 and 2. Okay, so these are all the boundary points that I got. Now let's compare all of the points that I got for this example to see which one is global mean, which one is global max. I found the point 1, 1, 1 as a saddle point, 1, 1, and then I need to find f of 1, 1. Plug in 1, 1 into here. 1 minus 2 plus 2 is equal to 1. What else? I got the point 0, 0 and the point 3, 0. I got the point 0, 0. The value of the function at the point 0, 0, it's 0. I got the point 3, 0. The value of the function at 3, 0 is equal to 9. What else? I got the point 0, 2. 0, 2. F of 0, 2 is equal to 4. What else? I got the point 3, 2. F of 3, 2. Just plug in 3, 2 into the given function. So I got 1, and what else? 3, 2, 0, 2 I already did, 3, 0 I already did, and then just 2, 2. 2, 2. F of 2, 2 is equal to 0. And as you see, I have the biggest one is equal to 9, so the point 3, 0 is global max, global maximum, and then I get a global mean for 0, 0 and 2 and 2, because the value of the function at these two is equal to 0, and it's the same. So the point 0, 0 is global mean, and also the point 2, 2 is global.